Hi friends, welcome back to a entirely new set of videos. This particular set is titled as Exciting Problems in Mechanics of Materials. We all know that for most of the mechanical engineering subjects and for a few of the civil engineering subjects as well, the topic of mechanics of materials is pretty much like a building block. So we all would have learned this subject in the maybe in the third or the second semester of our program. So in this segment, I'm going to solve some very exciting problems from this field. This will be useful for beginners as well as for the experienced or the persons who are working as engineers in the field. So without much ado, let's get started talking about the first problem. So the first problem is something like this. Before I describe the problem, to make the most out of these videos, I request all of you two things. The first, listen to the problem statement very carefully, then pause my video for a while, then try to solve this problem on your own. See, then only you will understand the nitty-gritty or the nuts and bolts of solving a particular problem. You will stumble upon something that will tell you what you're unaware of or what is your weakness. So I strongly recommend you to try the problem on your own before listening to the complete video. Make sense? So in this example, we have got a bar. We have got a round bar whose length is 2L and it is rotating about an axis through the midpoint C. And it is rotating with a constant angular speed omega. So I'm not talking about an situation where there is angular acceleration. This particular bar is rotating at a constant angular speed. A few other details so that you can solve the problem. The specific weight of the bar is gamma. Let me use a different color for the inputs. Oh my god, that is so faint. Okay, so this is gamma, which is the specific weight. Now the question is, derive a formula for the tensile stress sigma x. So you're asked to find out sigma x. Derive a formula to calculate sigma x as a function of x. So that is shown here. So I tell you a value of x that will define a particular section over here or here. For a negative value of x, the section must be somewhere here, maybe somewhere here. So I give you my x. The task in your hands is to come up with a formula or a function which will calculate the tensile stress sigma x. Make sense? So now pause the video, do it on your own. So as a first step, what I should do? Actually, for most of the mechanics problems, I believe drawing a free body diagram makes life a lot easier. That's what I believe. Now, in this particular problem, in this figure, I've shown it in 3D how the whole bar looks like. Then I have taken this section which is at a distance of x. Then you have a remaining portion of length L minus x as shown here. So let's magnify it over here. So this is the section at a distance of x and this is the remaining portion L minus x. Now I can ask you this question, what is the force acting on this particular section? The answer is very simple. See, there is this particular portion of the bar which is rotating at an angular velocity omega, so it will be obviously subjected to a centrifugal force or a centripetal force in whichever reference or frame you talk about. So this will be having an external force. This particular mass over here will be having an external force, will be experiencing an external force in the radial direction, which will be equal to the mass times the radius times the omega squared. That is the expression for mr omega squared. Sorry, that's an expression for the external force or the force that this particular chunk of mass will experience when it is rotating. Now the interesting thing is that the r is varying across the length, so I can't have a uniform, sorry, I can't have a single value for little r over here. For example, in this case, let's say I have a point mass, which is rotating at a disk with an angular velocity omega, and it is located at a distance of r, and let's say the point mass is mp, then this force acting on it mp omega square r. This is very simple over here. But in my case, since it is of length L minus x, I need to find out what is the net force acting on this particular section due to rotation. What should I do? I should integrate. So let me explain this. So I have isolated that second portion of the bar which is of length L minus x. Then I am introducing a new variable which will vary from 0, which will denote the section where we want to calculate the stress. It will be equal to little x is equal to little x. Then the c can vary till the end. That means c can assume a value from 0 to L minus 6. Now what I am calculating here, I'm taking a little chunk of mass over here and I'm calculating what is the force that this particular chunk of mass is experiencing. It will be the mass of that particular chunk of mass times the radius. Radius will be x plus c, because let me draw it over here again for you. So this is my total bar. My x starts, it is rotating about an axis somewhere here, and we are considering only this portion, this small portion. So till here it is x, and till this is the little c. Okay, so this is the axis. So that's why radius is x plus c. Then omega square. Omega is constant for the rigid body, so that makes sense. Now the simple maths, I don't think I have to show you all the steps or the math steps step by step. Even then I will do a few. A can be taken out of the expression because that is not varying with respect to my c variable. The area of cross section is the same across the length, so I can take A, I can take gamma because my material is homogeneous, I can take G outside, I can take omega square outside. So I'm left with 0 to L minus x, x plus c, omega square. Sorry, I've taken omega square outside, so there won't be any omega square. I'll be having only dz. If you do this, then you will end up with an expression like this: a gamma omega square by g into x into L minus x plus L minus x whole square by 2. Now this is the total force acting on this particular section over here. Let's say this is my center and this is the axis about which it is rotating. This is at, let's say, little x. So this is the total force. This is, let's say, This is the net force acting on the section N. I've calculated that. Now what is the stress? Stress is N divided by A, which will turn out to be, once you do all the maths, your final answer will be sigma x as a function of your x will be gamma omega square divided by 2g into L square minus x square. Okay, you have got an expression. Now just think, or just for a moment just verify whether this equation is correct or not, at least when the variables assume some extreme values. Let's say when my x assumes a value of capital L, that means I'm somewhere here or here. This is a bar of length 2L if you remember correctly. Then my stress values are assuming a value of 0. They are perfectly fine because they are free ends. I don't expect a stress on a free end. So this equation makes sense in that way as well. And moreover, when you put an x equal to 0, you're getting the maximum stress, which is at the center section. That also makes sense because at the center section, you have this entire mass rotating and causing a force on that particular section. So the maximum value of the stress will happen at x equal to 0, and the value will be gamma omega square L square divided by 2g. Thanks for watching. Tell me your comments so that I can come with more exciting problems in the next videos.